Yeah, good evening, Goyal. Good evening, Raz. Yeah, good evening, everyone. Raz, very soon it will come. Very soon, all will come. Very soon, all will come. So many changes are going on in the app. So many changes are going on in the development. Very soon, I am also eagerly waiting. I am also eagerly waiting. Website also coming. You can see from website also. You can see from website also. Can we start? Yeah, let's start. Let's start now. Topic name is recursion. Sairam, it is already right. You cannot keep everything in the right website, right? It will take most probably 3 or 4 days. Then everything will be on the web also. You can see. Yeah, maybe they got busy. Maybe they got busy. Right? Let's start. So, are you seeing everyday lecture that day only? Everyday lecture are you completing there only? Very difficult to view in app. Just on the app and you can sit some distance and you can see. Right? Fine. Let's start now. Let's start. Yeah, maybe mostly website will come. That time you can see whatever way you like. Now start now. So topic name is recursion. Right? Let's start. So actually in algorithm, first topic. Actually in algorithm, first topic is recursion only. The things which are needed for recursion, right? The things which are needed, right? We are already done. This is the correct time to start it. So please be careful from now onwards. Please be careful from now onwards. Right? In algorithm, it is the, in my opinion, in algorithm, it is the first topic. In my opinion, in algorithm, it is the first topic. Right? Please try to get everything. Please try to get everything. Right? I'm starting. Recursion. Can you help me now? Recursion definition. If anyone knows recursion definition. If anyone knows recursion definition. So what is the answer? A function. You can also type. You people also can type. What is the recursion definition? A function calling itself. A function calling itself to solve a problem. Is known as recursion. A function calling itself to solve a problem is known as recursion. A function calling itself to solve a problem is known as recursion. Careful from now onwards. Right? In algorithm, it is the first topic. Normally, other than me, if anyone is teaching algorithm, they will start from here. Right? So please be careful. So first topic in algorithm is recursion. So be careful from now onwards. Until now, lot of mathematical stuff you done. Until now, you done lot of mathematical stuff. You may not able to find out that mathematical things. Whatever happened in our classes, you may not able to find out. In our, right? Normally in any book in that math, right? That kind of mathematical stuff. All the things which are needed, I added one by one. All the things which are needed, I added one by one. Right? Those basics are very important. After those basics, right? This is the one which actually you have to start. So a function is calling itself is known as, right? A function is calling itself is known as, sorry, I'm repeating once again. A function calling itself to solve a problem is known as recursion. So, and one more thing. Do you have any doubts in the previous classes? First clarify, then we will go further. Do you have any difficulty, any doubt at anywhere in the previous classes? So remember, if you are studying each day, then you are the winner. If you are postponing, you are the loser. Please get everything whatever I kept in your app. In your course, whatever I kept, please get everything. Any doubt there, I created one group also. Everything you can post in that group. Everything you can keep in that group. You never find out that content. Saying one definition and leaving is very easy. Saying one definition, right? Saying the definition and leaving very easy. So that much deep I went. How to find out big O, how to find out omega, how to find out theta. What is the relation between them? Everything I explained. Any doubt there, please start posting in the group. I want to see some good work in the app. I want to see some good work in the group. Whatever you done in the group, anything you are not getting, immediately post in the group. Sir, please add full notes PDF also. You have to make your own notes. Roz, try to understand. You have to make your own notes. Others' notes is very difficult. It doesn't matter how much big notes it is. Others' notes is really difficult. You don't get my language. You don't get my language. You don't get some other's language. You please create your own notes. It will be really useful to you. Right? Please take care. Please take care, everyone. Right? You keep your, right? You write your own notes. Right? If you don't have the patience of writing your own notes, right? You never have the patience to get the good rank, to get the job. You don't have patience. Please start writing notes. Yeah, reference purpose I already kept. See, rankers notes I already there. They written their own way. I will keep still if I find out better notes. Some better notes if I find out, I will keep. Right? Start now. So I'm repeating once again. I'm repeating. Until now, whatever happened, those all are algorithms basics. So, right, in my opinion, algorithm class is just started now. Please be careful at least from now onwards. Whatever happened till now, it's fine. Whatever is happened till now, it's fine. Be comfortable at least now. Right? Start now. Right? So this only will come in the interviews. What is recursion? Can you explain? So you have to explain properly. First point, a function calling itself to solve a problem is known as recursion. Okay, recursion, right? That is fine. Let's take one example. Right, see the one example. Recursion definition I written. See the one example of recursion. See everyone listen. See the one example. I want to find out factorial of 6. Can you help what is the factorial of 6 value? I want to find out factorial of 6. What will be the factorial of 6 value? A function calling itself is known as a recursion. That's okay. I want to give one example. Please let me know what is the factorial of 6 value. Please give the answer to me. And one more thing. In every week, few classes I will take hybrid, few classes I will take live. Few is going to be recorded, few is going to be live. So that you will get the continuation. If I don't take live classes, you may be postpone also. In every week, few classes I will take live, few classes I will give recording, so that both will be done. So that you will be right. You don't postpone unnecessarily. Few live will be there, few recorded will be there. Complete each day work that day only. So let's start now. Factorial of 6 is equal to, listen, if I ask anyone what is the factorial of 6 value, if you know answer, factorial of 6 is 720. If you know, you say, what is the factorial of 6 value? Factorial of 6 is 720. If you know, you say. If you know, you say. Suppose if you don't know, listen. Suppose if you don't know, instead of saying I don't know, factorial of 6 I am asking. If you don't know factorial of 6 value, instead of saying I don't know, what you do is 6 into factorial of 5 you can do. Because you know factorial of 5. Factorial of 5 is assume 120. 120 into 6 is 720. If you know factorial of 6 is 720, say directly. If you don't know factorial of 6, at least one step go back. At least one step go back. Right? What is the meaning of step go back? Factorial of 6 I don't know, but factorial of 5 I know. Oh, factorial of 5 is 120. So 6 into 120 will goes to 720. If you know directly, you say 720. If you don't know, go one position back. Go one position back and say this. Some people are asking, sir, I don't know factorial of 5 also, sir. Do the same thing again. What is the answer? 5 into, go one position back. If you don't know factorial of 4 also, go one position back. Then factorial of 3 also. At least if you know factorial of 3, can you say what is the factorial of 3? Factorial of 3 is 6. At anywhere if you know, come back. I think factorial of 3 is 6. 6 into 4 is 24. 5 into 24 is 120. 120 into 6 is 720. Until the thing which you know will come, continue. Until the thing which you know will come, continue. Until the thing which you know will come, continue. Suppose assume that factorial of 3 also you don't know. Then 3 into factorial of 2. Factorial of 3 also if you don't know, then 3 into factorial of 2. So I hope everyone know factorial of 2. I hope everyone know factorial of 2. If you don't know factorial of 2, most probably everyone knows. If you don't know factorial of 2, in my opinion, everyone know. Unfortunately, if you don't know, 2 into factorial of 1. Unfortunately, if you don't know, 2 into factorial of 1. In my opinion, everyone know factorial of 1. In my opinion, everyone know factorial of 1. So, suppose if you don't know factorial of 1 also, you are not a human at all. Some people are saying, sir, I don't know factorial of 1. Then you are not a human. You are a dog. Sir, I don't know factorial of 1, sir. Then you are not a human. If you don't know factorial of 1, then you are not a human. Forget about recursion. Then you are not a human. So, someone asking factorial of 6. If you know, say directly. If you don't know, go one position back and say. Suppose factorial of 5 also if you don't know, go one position back and say. Instead of saying I don't know, just going back and whatever you know, accordingly planning. Factorial of 1 everyone knows. Factorial of everyone knows. Please careful. Now can anyone help me now? What is the factorial of 1? Can anyone help me? What is factorial of 1? Everyone know factorial of 1. What is factorial of 1? Everyone know. If you don't know, you go to hell. Are Dinesh, if you don't know factorial of 1, you go to hell. Everyone know factorial of 1. Everyone know. Right. So some people are asking, sir, if I know what will happen, sir. Can you see this? If you know what will happen. Listen. If you know what will happen, you can see. If you know what will happen. If you know, you have to go back. See, factorial of 1 is 1, right? 2 into 1 is 2. So remember, listen, remember from which place you came, that place result will go 2. 3 into 2 is 6. From which place you came, that place result will go 4 into 6, 24. From which place you came, that place result will go 5 into 24, 120. From which place you came, that place result will go. Next one, 6 into 120, 720. From which place you came, that place result will go. Right. So can you help me now? After this example, please confirm me. After this example, please confirm me. What is the meaning of recursion? What is the meaning of recursion? After this example, please let me know what is the meaning of recursion. So I'm doing one small thing. Can you see this one? I'm doing one small trick. Can you see this one? Can you see this one? Listen everyone now. So function name is f. Function name is f. See this one. F calling f. F calling f. F calling f. That is called recursion. A function is calling itself is known as recursion. A function is calling itself is known as recursion. Recursion definition saying that a function is calling itself. A function is calling itself is known as a recursion. See, f calling f, f calling f, f calling f, recursion. Right. Now, and one more thing. Listen, one more thing. Oh, Sai Kumar came. Hi Sai, how are you? Now listen. Now listen everyone. Everyone listen. Everyone listen. Recursion means, listen, recursion means calling the same function. Okay, listen. When you say same function, same work also. When you say same function, means same work also. What is the meaning? See this one. Every time multiplication. Same work also. When you say recursion, calling same function again, means same work again. See, everywhere multiplication. Everywhere multiplication. Sai, all the best. Now listen, again I am asking you, recursion means a function calling itself. Okay, everyone know. When you say a function calling itself, okay, same function calling means same work. What is the meaning of same work? Everywhere multiplication. Everywhere multiplication, see. Suppose assume that, see this one, sometimes addition, sometimes subtraction, sometimes multiplication, sometimes division, then you cannot go for recursion. Recursion means every time same story. Every time multiply, then recursion. Every time divide, that is also recursion. Every time add, that is also recursion. If you are doing every time same. If you are doing every time same, that is called recursion. See, everywhere multiplication. Right? A function calling itself. Calling itself means doing same work. Doing same work means every time multiplying. Every time multiplying. I hope you really comfortable. Listen, from today onwards, if anyone asks you, explain recursion, simply say like this one. A function calling itself is known as recursion. They will ask you, can you give an example? Give this example. If I want to find out factorial of 6 value, if you know answer 720, say directly 720. If you don't know, instead of saying don't know, go one position back and solve it. 6 into factorial of 5. Sir, if I don't know factorial of 5 also, recursion. What is the meaning? Do similar work. 5 into factorial of 4. Sir, if I know factorial of 4, then come back. If you know, come back. If you don't know, go down. Factorial of 4 also you don't know, go down. 4 into factorial of 3. Factorial of 4, factorial of 3 also you don't know. 3 into factorial of 2. If you don't know, go down. If you know, go up. If you know, go up. If you don't know, go down. Okay, now because of you understood, can we see the next one? Listen everyone now, second point. Everyone listen, second point. Everyone listen, second point. A recursion is nothing but calling itself. I given one example also, everything is fine. Listen, if you want you can see the program also. See the program roughly. See the program roughly how I am writing. See this one, fact of. See the program roughly. Fact of n inside. Fact of n inside n into fact of n minus 1. Something there before, right? So fact of n inside n into fact of n minus 1. So I written roughly. Yeah, someone is saying that is also, but mostly when recursion is going on, it will decrement. That is also recursion. See, that is the reason, if you see the definition, a function calling itself is known as recursion. A function calling itself is known as recursion. Right? But when you say recursion, see, f calling f, inside f, there is a f. Inside f, there is a f. Now can you come to here? Listen, can you come here now? I think definition is done. One example also given. I written one program also. This is the how recursive programs are they. F calling inside F. F calling inside F. F is calling inside F. So I given one example. Now can you come to here? Can you come to here? Second point. Listen, everyone listen. Everyone listen. If you observe properly, everyone listen. If you observe properly, see this one. Factorial of 6 is solved using factorial of 5. Factorial of 5 is solved using factorial of 4. Factorial of 4 is solved using factorial of 3. Factorial of 3 is solved using factorial of 2. Factorial of 2 is solved using factorial of 1. That means, right? Factorial of 6, bigger one is solved in terms of smaller one. Recursion is nothing but, right? Bigger one will be solved in terms of smaller one. Remember from today onwards, recursion is nothing but. Recursion is nothing but. Recursion is nothing but solving big problem into solving big problem in terms of smaller problem. Solving big problem in terms of, right? Recursion is nothing but solving big problem in terms of smaller problems. Recursion is nothing but solving bigger problems in terms of small problem. Solving big problem in terms of smaller problems. Right? So please careful. From today onwards, if anyone asks you, right, say the recursion definition. Say second point. Second point indicates you know about recursion. You are solving bigger one in terms of smaller one. You are solving bigger one in terms of smaller one, which is known as recursion. So if you okay till now, I can go to the third point. Can you say what is the third point? If you are okay till now, I can go to the third point. Anyone having any doubt? Recursion is nothing but calling itself. Right? Recursion is nothing but solving big problem in terms of smaller problems. Please verify. Anyone having any doubt? Arey Goyal, can I go to next? Yeah, so Goyal is saying something. You will get to know whatever happened. Please take care. See, don't talk something by imagining. Whatever I said, just follow. Whatever I said, just follow. Right? They will come. Whatever you are talking, maybe they will come further. So you can represent tree in the array also, in the linked list also. You can represent tree in the array also, linked list also. Array, see, someone is saying when not to apply recursion. Array, Gootle is just started definition. Recursion definition just started. Definition started. Whatever is going on, please take care. Don't talk more. If you talk more, it will trouble others. Right? Definition is over. Right? From today onwards, if anyone asks you what is recursion, say second point. From today onwards, if anyone asks you what is recursion, say second point. Recursion is nothing but solving bigger problem in terms of smaller problem. Recursion is nothing but solving bigger one in terms of smaller one. From today onwards, anyone ask recursion definition, please say this. If you say first one, nothing special. If you say first definition, nothing special. Say second one. When you say second one, they will ask you, can you explain? Then explain this example. Factorial of 6 I want to calculate, but unfortunately I don't know. So what I do is, right, I will write the factorial of 6 as 6 into factorial of 5. Means factorial of 6 you are solving using factorial of 5. How you solve factorial of 5? Factorial of 5 I will solve using factorial of 4. And so on. So in the total hierarchy, if you know one person also, you can go back. In the total hierarchy of this diagram, if you know one person also, go back. See, red color is going back. Green color is going down. I don't know, go down. I don't know, go down. I don't know, go down. You know, go up. You know, go up. You know, go up, and so on. Okay, fine. Now listen. Now listen, everyone. Everyone listen. Everyone listen. Please help me. Please help me. Factorial of 6 if I want to calculate totally how many function calls? Factorial of 6 if I want to calculate totally how many function calls? Can you see? 6 calling 5, 5 calling 4, 4 calling 3, 3 calling 2, 2 calling 1. How many? Yeah, that is the reason. That is the reason. So please follow. Factorial of 6 if I want to calculate including 6 how many? Factorial of 6 if I want to calculate including factorial of 6 how many? I think 6 function calls. Including factorial of 6, yeah. 6, 5, 4, 3, 2, 1. How many? Including factorial of 6, totally 6. If I want to find out factorial of 6, including factorial of 6, totally 6 function calls. Remember everyone, listen. Remember everyone. See this one. Many function calls. 6 calling, right? If I want to find out 6 will call 5 will call 4. Many function calls. Remember, whenever recursion is going on, not one function call, not two function call, many function call. Whenever you say many, you only say in a particular family, many people are there. Definitely house required. If one person, you can stay on the main road. If two people can stay in railway station. If one person can dance on the main road. If one person can dance on the national highway. If many people are there, house required. That is the reason when you say recursion, many function calls are there. When you say recursion, many function calls are there. So those all function calls should wait somewhere. That is called stack. Remember. So I am writing this one. To execute recursive program, we are using stack data structure. Please careful. Right? One function call you can store somewhere. Two function call you can store somewhere. One function call, one variable you store. One more function call, one more variable you can store. Those many function call where I will store here. That is the reason to execute the recursive program we are using stack data structure. One person you can manage somehow. Two people you can manage somehow. More people are there. You have to use, right, some data structure. The data structure which you are using is stack. Remember to execute the recursive program. Internally computer uses stack. This is a stack. Computer uses stack. This is a stack. To execute the recursive program, computer uses stack. That is the third point. To execute the recursive program, computer uses stack. One person I can store some way. Two people I can store some way. These many people. I have to take one data structure. I have to store. The data structure which you are using here is stack. And one more important thing I want to say to you. Listen. One more important thing I want to say to you. Arey Goyal. Mind your language. Goyal, mind your language. Don't ask me in between. It will kill other people. It will kill other people. Please take care. Goyal bhaiya, kill me yaar. Kill me. Goyal bhaiya, kill me. It will kill other people. Until now, when I am taking recording class, I am very happy because Goyal not there. Whenever I am taking recording class, I am very happy because Goyal not there. Whenever live, Goyal will come. Whenever live, Goyal will come and he will eat me. Goyal eat me like I am a dosa. Like dosa, right? He will eat me. He will eat me like a idli. He will eat me like a puri. Just I started. When I say stack, immediately is asking, right? 2 stacks, multiple stack, 3 stack, 4 stack. Just I used one keyword stack. Then he started. To execute recursive program, we are using stack data structure. So careful. Next one more important thing. Can you see this? One more important thing. Listen everyone. If you observe clearly this program, see this one. F6 calling F5, F5 calling F4, F4 calling F3, F3 calling F2, F2 calling F1. Remember, this green color is called calling. Calling means push operation. He is a dog running behind you. You just shut your mouth. Array reality search. You just mind your language. You just shut your mouth. And listen. Can you help? Listen everyone now. So this green color is calling. Calling means push operation. Every function call is a push operation. See this one. F6 calling F5. Okay, push operation. F5 calling F4. Push operation. Calling means push. From today onwards, you remember, anywhere function call, push. Anywhere function call, push. Can you help me one small line? Anywhere function call, push, okay. Can you help which function completed? Function call means push operation. That's okay. Can you help which function call completed first? The function which called first is F6. F6 called first. See, F6 called first. F5 called next. F4 called next. F3 called next. F2 called next. F1 called last. The person who called last is F1. The person who called last is F1. The person who called first is F6. The person who called last. The person who called first is F6. The person who called last is F1. Can anyone help? Who will execute first? Called last is F1. But who will execute first? Remember, the person who will execute first is F1. Called is F6. Called first is F6. Called last is F1. But the person who completed first is this one. The person who completed first is this one. Next he completed. 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 So what I want to say, the person who called last, he will complete first. The person who called first, he will complete last. Remember. So right, in terms of execution, the person who called last will execute first. The person who called first, he will execute last. That is the meaning of stack. What is the meaning of stack? Stack means last in, first out. Stack means last in, first out, or first in, last out. This is the meaning of stack. The person who called first F6. The person who called last is F1. But the person who completed first is F1. Who completed next is F2. Who completed last is F6. That is the reason it became stack. That is the reason, see this one. To execute recursive program, we are using stack data structure. To execute recursive program, we are using stack data structure. Now, those people who are having small doubt also, can you type in the chat? Those people who are watching, can you type in the chat? Who called first, who executed first? Can you type all? All the people type. Who called first, who executed first? Who called last, who executed last? I want answer from you. Who called first, who executed first? Who called first, who executed first? Who called last, who executed last? I want answer. Everyone can type. Please type. Who called first, who executed first? Who called last, who executed last? I want answer from you. Everyone have to type. Called first to execution first to. Called last to execution last. I want answer. Everyone type. Type everyone. And one more thing. Whoever, listen, one more thing. Function call means push. Function over means pop. Function call means push. Function over means pop. Call means push. Over means pop. I want answer from you. Who pushed first? Who pushed next? Can you say push order? Can you say pop order? I want answer from you. Push order, pop order I want. Calling means push. Execution means pop. Oh, function calling, push. Oh, function over, pop. Oh, function calling, push. Function over, pop. Don't sit idle. So I want answer. Who called first? Who pushed first? Who pushed next? I want push order. I want pop order also. I want to push order. I want to pop order also. Call means push. Over means pop. See, those people who are not typing. If anyone is not typing, you are a pig. To execute recursive program, we are using stack data structure. Call means push. Execution over means pop. I have typed first. Good boy. Goyal is a good boy. Is a very good boy. To execute recursive program, we are using stack data structure. Can anyone help me? Can I use queue data structure? To execute the recursive program, can I use queue? If at all queue data structure, if I use queue data structure, right, F6 came first to push first to. F6 came first to, right? So F6 will push. Immediately F6 will pop. If I use queue data structure, F6 will push first to, F6 will pop. Push pop immediately. Then why are you pushing? Why are you popping? If anyone says, sir, why are you using stack, sir? Why not queue? Queue is first in, first out. F6 I called first, so push. F6 only over first, so pop. You push first, then you will pop. What is the use of it? How can you complete F6 without F5? How can you get it? Without completing F5, how F6 will come? Without completing F4, how F5 will come? So that is the reason. To execute the recursive program, we are using stack data structure. Those people who are watching the class, please give answer to me. Those people who are watching, please give answer to me. If you are watching this class, please give answer to me. I am expecting answer from everyone. Give one application. From today onwards, if anyone asks you, give one application of stack. So what is the answer? From today onwards, if anyone asks you, give one application of stack. What is the answer? Recursion. Give one application of stack. Recursion. Give one application of queue. Every data structure having some application. Every data structure having some application. Can you say one application of queue? One application of queue is in movie theater ticket counter. One application of queue is in movie theater ticket counter. In movie theater ticket counter is, right, queue. Right? One application of stack is recursion. One application of queue is movie theater ticket counter. If you go to the movie theater ticket counter, in the ticket counter, whoever came first to, he will get ticket first. In the movie theater, whoever came first to, he will get ticket first. Suppose movie theater ticket counter, if I keep the stack, people will kill each other. Movie theater ticket counter, if I keep stack, people will kill each other because the person who came first, he will get ticket first. The person who came first, he will get the ticket last. The person who came late, he will get ticket first. So in the movie theater, you have to keep queue data structure. To execute the recursive program, you have to use stack data structure. So remember, every data structure is good. So correct place, use correct data structure. Some people are asking, what is the meaning of data structure? The one which can store data, that is called data structure. The one which can store data, that is called data structure. The one which can store data, that is called data structure. Stack is a data structure. Queue is a data structure. Array is also data structure. Linked list also data structure. I am repeating once again. What are the data structure? Stack, queue, linked list, tree, array. I am repeating once again. What are the data structure? Stack, queue, array, linked list, tree, graph, something like that. Data structure purpose is storing data. Data structure purpose is storing data. One way, right? One way of storing stack format. One way of storing queue format. When I will go for stack, if you want last in first out behavior or first in last out behavior, go for stack. When will you go for queue? If you want first in first out behavior, or if you want last in last out behavior, go for queue. So from today onwards, if anyone asks you, say one application of stack, I am repeating once again. From today onwards, if anyone asks you, say one application of stack recursion. There may be many. One application I am saying. From today onwards, if anyone asks you, say one application of queue, movie theater ticket counter. Someone is saying storing data in main memory or secondary memory, wherever it is. Wherever you want, you can store. Wherever you want, you can store. Okay, fine. Fine, that is okay. Now come to the next one. So to execute recursive program, we are using stack data structure. Now listen. Listen everyone. Everyone listen. Everyone listens. Listen carefully. One very, very important one. Otherwise it will mislead you. The thing which I am going to say to you, it will mislead you. Can you see everyone? Can everyone see? Function call is a push operation. See everyone. Function call is a push operation. F6 called push. F5 called push. F4 called push. F3 called push. F2 called push. F1 is called push. So function call is a push operation. Can you help me now? If you keep on calling, listen, if you keep on calling, let us assume, right? F1 push, but F1 is calling, let us assume, F1 is calling F0 push, F0 calling F minus 1 push. Remember, every function call is a push operation. If you keep on calling, if you don't stop at any way, if you keep on calling, I think in the stack you are keep on pushing. Keep on calling means keep on pushing. Keep on calling means keep on pushing. If you keep on push, stack space is over. This, right? Stack is almost like this. Stack is almost. First you called F6. Next you called F5. You are keep on calling. Every function call is a push operation. Every function call is a push operation. When you keep on call, some place you have to stop. If you don't stop, some place you have to stop. If you don't stop, right, at some point of time, stack size is over. This also over, this also over, this also over, this also over. Further not there, but still you are calling. Every function call is a push operation. You are keep on calling means keep on push. Some point of time you have to stop. If you don't stop, stack is overflow. Then you will get error message stack overflow. Then you will get error message stack overflow. So that is the reason people used to say that every recursive program should have termination condition. At one place you have to stop. At one place you have to stop. If you don't stop, you are keep on calling, means keep on push operation, stack space is over. Every recursive program should stop somewhere. That point is called termination condition. Every recursive program should stop somewhere, means from somewhere you have to come back. From somewhere you have to come back. If you don't come back, if you keep on calling, so keep on push. But every data structure having some limited size. You are keep on calling, keep on push. Everything having some boundary. So stack also inside a computer have some space. Stack also inside a computer have some space. That space also over. If you keep on push, some point of time space over. So it will leads to stack overflow error message. Can you see this right? Fourth point. Every recursive program should have termination condition. Every recursive program should have termination condition. Every recursive program should have termination condition. Otherwise, we will get error message, stack overflow. Otherwise, we will get error message, stack overflow. People are thinking that, listen, people thinking that, sir, stack overflow means stack overflow website. Oh, right, termination condition not there, right? We will go to stack overflow website. One Gootle misused the name. It is not stack overflow website, yaar. It is a stack overflow error message. Every recursive program should have termination condition. Otherwise, we will get error message, stack overflow. Some people are thinking, sir, will I go to stack overflow website? No, yaar. No, they are misusing. The person who kept stack overflow is a Gootle. The person who kept the name stack overflow is a Gootle. How he can misuse it? How he can misuse, yaar? I want to file a case on him. The person who kept stack overflow, I want to file a case on him. How he can misuse it? Every recursive program should have termination condition. Otherwise, we will get error message, stack overflow. I want to file a case. How can you do this? Can't you see something else? How can you misuse? My students are thinking stack overflow means stack overflow website. Stack overflow means stack overflow website. My students are misused. My students are innocent people. They are misused. Misuse. Stack overflow, bhaiya, please remove that name, yaar. Stack overflow, bhaiya, please remove, yaar. My innocent students are unnecessarily trapped. They are unnecessarily trapped. Every recursive program should have termination condition. Otherwise, we will get error message, stack overflow. Remember, it is not website. See this one. Error message, stack overflow. Not website, stack overflow. Otherwise, we will get error message, stack overflow. Not website, stack overflow. Be careful. Be careful this one. Sir, my doubt, please. Sir, can you solve 2021 graph question? Shashank, if I jump on, I will jump and I will kick on your nose. Seriously, recursion going on. He came and he is saying, sir, can you solve 2021 gate question? Seriously, stack is seriously, recursion going on. This joker is came and he is saying, can you solve 2021 gate question? Gootle, common sense not there. Don't you know where to talk what? Shashank, you send that doubt to me. Tomorrow, rank improvement course, I will solve it. Tomorrow, rank improvement course, I will solve it. You send to me. You came to recursion class, you are asking, right, graph theory question solve. Common senseless fellow. Going to movie and studying. Studying time watching movie, common sense not there. Chalo, next one, I think fourth one is over. Every recursive program should have termination condition. Otherwise, we will get error message, stack overflow. In group I send, then why are you sending here? Right? So I will take care. Send to me personally also, Shashank, if you want. Come to the fifth point. Every recursive program should have termination condition, otherwise we will get error message, stack overflow. Yeah, I am absolutely fine with this. I am absolutely fine. Now, can you see this? Everyone listen. Can everyone listen? So Shashank is saying sorry. Arey Shashank, no sorry yaar. No sorry. Just casually I said. You no need to be emotional. You can be shameless fellow like Goyal. Goyal don't have shame. You also can be like Goyal. Goyal anyhow don't have shame. Goyal don't have shame. You also. Why you take serious? Right? Take the inspiration of Goyal. Shameless fellow is. Now I think one interesting one. Can you help me now? Listen. If you don't have a, listen, in the recursive program termination condition not there. So every function call push. Because of lack of space. Right? You are keep on pushing, space not there. You will get error message. Remember everyone. It is a runtime error. It is not a compile time error, right? Running time, this problem will happen. Compile time, no problem. I am writing here. Runtime error. Nice point. Thank you so much for informing. It is not a compile time error. It is a runtime error. It is not a compile time error. It is a runtime error. Careful. I am shameless fellow, sir. I know, sir. Shashank Bhaiya, I know. Shashank Bhaiya, you are shameless. I know. On national highway, you are dancing also. On NH5, while going in the car, I seen you. You don't have any shame, Bhaiya. You are dancing on the national highway. Right, now come to the next one. Don't divert the topic. Can you see the fifth statement? Very, very interesting one. Can you see the fifth statement? Everyone listen. Can you see the fifth statement? So every recursive program should have termination condition. See how the recursive program will be written. Everyone listen. How the recursive program will be written. Factorial of n. See this one. This is the roughly program. Factorial program is like this one. Please don't worry that much about syntax. I am just giving idea. Factorial of n. Listen. Factorial of n. Everyone listen. Factorial of n. See this is the way. If anyone asks me what is the factorial of n value, first question I will ask is if n is less than or equal to 1. If n is less than or equal to 1. If someone asks me what is the factorial of n value, I will just ask first question. Is n is less than or equal to n? True. If true, return 1. Else. So factorial of n how much? Suppose someone asking me what is the factorial of 6 value. I will ask is 6 is less than or equal to 1. If true, return 1. Else, listen, 6 into fact of 5. Else return n into fact of n minus 1. From today onwards, if anyone asks me, please write the factorial program. Very simple. Right? From today onwards, everyone remember. If someone asks you, can you write the factorial program or any program, recursive program, please write. Someone asking me recursive program, please write. Someone asking me, please write the recursive program. Remember, in the recursive program, first step is termination. It is for termination. First write termination. In the recursive program, first step is termination. If termination, no need to go further. If not termination, come here. Every recursive program contains two parts: termination, non-termination. Termination, non-termination. So if condition satisfied, termination. If condition fail, non-termination. Recursive program contain only two steps: when to stop, if not stop, how to continue. When to stop, if not stop, how to continue. Recursive program is very easy to write because only two steps are there. Recursive programs are very easy to write because only two steps: termination and non-termination, or if and else. If condition, else condition. That's it. What is if, what is else? Please write it. Someone is asking, why not n is equal to 1? Remember, if someone asks me, what is the factorial of 1? Then also 1. What is the factorial of 0? Then also 1. What is the factorial of minus 1? Then also 1. What is the factorial of minus 55? Then also 1. Remember everyone. Factorial of 1 is 1. Factorial of 0 also 1. Factorial of minus 1 also 1. Factorial of minus 55 also 1. That is the reason. Yeah, perfect. Now listen everyone now. Recursive programs contain how many parts? Everyone type in the comment section. Everyone type. Recursive program contain how many parts? Please type everything. Recursive program contain how many parts? 2 parts. What are those? Termination, non-termination. Or one more way of saying, if and else. If part, else part. Not only this one. Every recursive program contain only 2 parts. If part, else part. Or termination, non-termination. Termination, non-termination. If part, else part. And one more. Recursive programs are very easy to write. Why? Only 2 parts. Recursive programs are very easy to write. Why? Only 2 parts. If part, else part. Can you help me now? Which one is the first part? It having 2 parts. If part, else part, okay. But what is the first part? First part is if part. First part is the termination. You cannot write the non-termination first. Right? Recursive program contain 2 parts. If part, else part. First is termination. Check termination first. If not termination, then go to non-termination. If not termination, then go to non-termination. Don't write the non-termination first. If you write the non-termination, see this one. If anyone say, sir, I will swap, sir. If anyone says, sir, I will swap, sir. Some people are asking, sir, I will swap, sir. Then what the meaning of swapping is, right? N into fact of n minus 1. You written here, right? Also, if n is less than or equal to, suppose assume that if anyone swapped, if part, else part, if anyone swap, what happened is, can you see this one? 6 will call. Everyone listen. If you swap them, see the unfortunate thing what will happen. If you swap them, 6 will call 5. 5 will call 4. 4 will call 3. 3 will call 2. 2 will call 1. 1 will call 0. 0 will call minus 1. So it never reach this area. So be careful. Every recursive program contains 2 parts. If part, else part. If part, else part. If you write, you have to write if first to try termination. If termination working, don't go to else part. If termination not working, then go to else part. If you swap it every time function call because you are not checking. Someone is saying how RR today. What is RR? RR means today discrete lecture off. It is not there, na? Piyush Bhaiya, it is not there, na? Can you see that? Can you see the schedule? How RR today? How RR today? It may come, maybe. Let's see. Let's see. Now last one, everyone can observe this. Everyone can observe. Listen everyone now. Recursive program writing is so easy. Recursive program writing so easy because only two parts. If part, else part. Termination, non-termination. But remember, termination should be written in the first place. If anyone try to swap, if anyone swap the if condition, else condition, remember, again Stack Overflow error message will come. How to attend discrete maths class? Arey, that is a rank improvement course. Arey, Goyal, why don't you do Bharatanatyam on my head? Why don't you do Bharatanatyam on my head? Goyal Bhaiya, why don't you do Bharatanatyam on my head? That is for rank improvement course. That is not for you. Why don't you dance on my head? Right? That is for right practicing questions. Practicing high quality questions. They are already there in your app. In the app already available. Please go and read it. In app already they are available. Please go and use it. Right? Next year it will be useful to you. Piyush Bhaiya, today class not there Bhaiya. You came suddenly and you are seeing. How is it practically possible? Chalo then. So let's see this one. Yeah, so I think everyone is fine now. Can everyone observe? One important point is coming. Can you see this one? Can you carefully observe? Everyone carefully observe. See this, everyone carefully observe. So if you want, it's not n actually, it is in 10. It is actually in 10. Remember, it is actually in 10. Careful. It is in 10. If you want, I will change it. Programming way, it is in 10. It is a programming way in 10. Now everyone listen. It is in 10. See how this program is running. I am explaining. So we are already done, right? We are already done that class, right? Please check one time. We are already done that, right? Please see one of the YouTube class is there. Please check. Yeah, fine. That's okay. Can you come here now? I think everything is fine now. Please concentrate everyone. Here. Please concentrate everyone. See this one. How this program is running. Everyone listen. How this program is running. Assume that n value 6. See how this program is running. Listen everyone now. How this program is running. Everyone I have to observe how this program is running. So what happened is, listen, first factorial of 6 called because n value 6. First factorial of 6 called. Can everyone listen? Factorial of 6 called. Remember, f of n called. Factorial of in 10, right? F of n called. N value 6. Remember, in 10 means integer means 2 bytes. In 10 means create 2 bytes of memory. See this one. When you say f of n, where n is 6, in 10 means for the n memory will allocate. So when you say fact of n, it is a fact only, lack of space, I written f. A fact of in 10, right, where n value 6. When you say fact of n, where n value 6, for the n 6, some memory location is created. int n means create 2 bytes of memory. I created. And one more thing, remember, function call is a push operation. So f of n is pushed where n is 6. F of n is pushed. Function call means push operation. Factorial of n means factorial of n is pushed where n is 6. Now can you help me? What inside code? N value 6. Inside code n value 6. 6 less than or equal to 1, condition fail. Then you will come to else part. Can you say what is the else part? Everyone observe else part. N into fact of n minus 1. One important thing is it is a function call. It is a function call. Again push. Again f of n where n is 5. Remember everyone. Listen. Remember everyone. F of 5. 6 minus 1 means 5. F of 5. So fact of 5. Everyone listen. Fact of 5 is called. Again you will go there. Previously n value 6. Now n value 5. 5 is came. Now when you say function call push operation again. So push done. Right now again termination condition. See n value 5. 5 less than or equal to 1 if condition fails. So else same. N into fact of n minus 1 return. So again f of n minus 1. N is 5. 5 minus 1 means 4. So f of 5 minus 1 which is nothing but f of 4. 4 will go there. So f of n where n is 4. Value is 3000. Again same code. That is the meaning of recursion. See this one. Are you identified or not? Every time same code. Are you identified or not? Every time same code. So n into f of n minus 1. Again it is a function call. Again push. But here n value 3. Right? Somewhere memory created 4000. So remember every n memory will allocate. When I say first time int n, listen. This int n is executed 6 times. 6n will create. Int n means creating memory first time where n value 6. When you call second time again int n where n value 5. Int n means again create memory. When you come third time int n where n value 4. Again create memory. Next one 4 minus 1 which is 3. Int n where n value is 3. Again create memory. Next one 3 minus 1 it is a 2. Right? Int n where n value 2. Next one 2 minus 1 it is 1. Right? Int n where n value 1. Right? Now listen, n value 1, this condition true. 1 less than or equal to 1. Return 1. This is the first return. This is the first return. Now let me do one time. I think almost you are okay. N into f of n minus 1. Get as maximum as possible. Again same. F of n minus 1. F of n will push where n is 2. Again memory will created 5000 at 5000 memory location. Int n means creating memory. First time int n this memory created. Second time int n this memory created. Because same code you are running again and again. Third time int n this memory created. Fourth time int n this memory created. Fifth time int n this memory created. Can you see the one more time? Can you see one more time? Again f of n where n is 1. Address is 6000. Address is 6000. Now listen now. Now this f of n where n is 1. This condition true. Listen. This condition true. Return 1. So he will return 1. He will return 1. So this code is n into f of n minus 1. Almost you are okay. Almost you are okay. Now carefully observe. Careful everyone. Whoever watching this class. Please help me. In the stack now where are you? Don't confuse. In the stack where are you now? Those people who are watching, please let me know. In the stack where are you now? On the top? Those people who are watching in the stack now, where are you? On the top? In the stack where are you? On top? Calling. Now you are on the termination condition. F of n. Now you are on the termination condition. Remember how many times you called those many push. How many times you called those many push operations. How many times you called, those many push operation. Can anyone help you now? Right? Wherever you are in that box, what is the n value? How many times you called, those many n value. Wherever you are, what is the n value? Soumya, please say. Soumya, please say, wherever you are now, what is the n value? How many times you called, those many push operation. That point of time, whatever n is there, that will be created. Int n creating memory. Int n creating memory. First time int n memory created n value 6. Second time int n again. Because same code you are running. Again memory created 2 bytes. Every memory having some address. So first memory location 1000. Second memory location 2000. Third memory location 3000 and so on. Last memory location is 6000. Now let me ask you, wherever you are at that place, what is the n value? 1. And one more thing, listen, one more thing. Whenever this 1 is coming, there, listen, return 1, return means pop. When you say return means pop. Listen, when you say return, this is popped out. That return value will comes to from which place you went. So that 1 will comes to here. Return means pop. You pop it, the returning value will goes to from which place you came. Can you help in this block n value 2. 2 into 1, 2. Again, right? Again, see this one. Return. So this 2 will be written here. But remember, return means pop. Again, what is the n value in this block? 3. 3 into 2, 6. There is a return. Every time, see, when you come to else part, return is there. Every time there is a return. So you will go here. This is 6. What is the n value here? 4. 4 into 6, 24. Always remember, when you say return, from which place you came, that place you will go. It is the 24. N value here 5. 5 into 24, 120. 120. What is the n value here? 6. 6 into 120, 720. 720. So remember, listen, this green color coming down means pop. Pop means return. This green color coming down means pop. Pop means return. Function calling means push operation. Function calling is push operation. Function calling is push up. Whatever way you came, same way you will go back. Yeah, n is equal to 1. See this one. This is the first return. See this one. First return is this. This is the first return. Everyone listen. This is the first return. This is the second return. This is the third return. This is the fourth return. This is the fifth return. This is the sixth return. Green colors are coming every time return. See. So remember, first return is here. Remaining returns here. Every function call is a push operation. Every function over pop operation means return. Now again I am asking you. Please help me. In every slot, how much memory created? In every slot, how much memory created? 2 bytes in 10. 2 bytes in 10. How many bytes created? 2 bytes. In every slot, 2 bytes. In every slot, 2 bytes. In every slot, 2 bytes. Because in 10, to store n value, you are creating memory. To store n value, you are creating memory. Remember, this is there inside only. For your convenience, I written outside. Every time for local variable, memory will allocate. Local variable in 10 memory will allocate. Every slot 2 bytes of memory, because every slot in 10 2 bytes. So first question, can you type one by one? Whenever recursion is going on, are you using stack data structure or not? Please type all the things. whenever recursion is going on, are you using stack data structure or not? Yes. Are you using stack data structure or not? Yes. Right? Like this stack data structure. Whoever called first, he will push. Whoever called next, he will push, and so on. Lastly, termination condition will happen. Lastly, termination condition happened, you will start popping. Going time push operation. So red color things are push operation. Red color things are push operation. So I will write this also. Just let me please give the answer to me. Red color. Red color also I am writing. See, this is called red color. You will go here. This is red color. You will go here. This is red color. It will go here. This is red color. It will go here. This is red color. It will go here. Right? Whenever termination condition happened, green color coming down. Green color coming down. Red color going up. Green color coming down. When you say coming down, 2 bytes are popped. When you are coming down, 2 bytes are popped. When you are coming down, 2 bytes are popped. When you are going up, 2 bytes are pushed. 2 bytes memory push. 2 bytes data push. 2 bytes data push. When you are coming down, 2 bytes data pop, and so on. Push pops are going on. Now it's a very important question. Listen, it's a very important question. Please careful. It's a very important question. Everyone try to catch it. Everyone try to catch this. Whenever recursion is going on, whenever recursion is going on from one function call to another function call, what is the change? Whenever recursion is going on, listen, whenever recursion is going on from one function call to another function call, what is the change? What is the change? Remember, whenever recursion is going on from one function call to another function call, what is the change is, right? Function name will not change. Parameter name also will not change. Number of parameters also will not change. Code also will not change. Whenever recursion going on from one function call to another function call, function name will not change. Parameter names will not change. Name of the parameter also will not change. Code also will not change. Same code. The only thing which will change is parameter value. Value will change. This is the value. One function call to another function call, I am writing that point also. To say that point only, I done this much work. 5 is over. Can you see the 6th point? See the 6th point. In recursion from one function call to another function call, in recursion from one function call to another function call, in recursion from one function call to another function call, parameter value will change. Parameter value will change, but not other things. Please take this. In recursion, from one function call to another function call, from one function to another function, parameter value will change, but not other things. In the first function call, n value 6. In the second function call, n value 5. In the third function call, n value 4. But the important thing is code is same. Important thing is function name also same. Important thing is variable name also same, n. If anyone having small doubt, can you see this one? Variable name. If anyone having small doubt, can you see this? If anyone having small doubt, can you see this one? F of n. Variable is, see this one. Function name same. One function call to another function call. Function name same. Parameter name also same, n. Parameter name also same, n. But parameter value will change. Value 4 here. Value 5 here. Value 6 here. One function call to another function call. In the recursion, parameter value will change, but not other things. parameter value will change, but not other things. So please remember. So learn all. If anyone thinking, sir, I am not getting, sir, concentrate more. No one knows. I also don't know. Until unless I prepared, I also don't know. In the BTech, no one knows. Sir, while studying BTech, I didn't study it, sir. No one studied. BTech purpose is different. Sir, whenever BTech is going on, I don't know all these things, sir. I don't know all these things. Not only you, everyone knows. That is not the purpose of BTech. BTech purpose is not recursion. BTech purpose is dancing in the canteen. BTech purpose is right, dancing in the campus, dancing in the right canteen, doing some nonsense in the college. That is the purpose of BTech. BTech purpose is not recursion. In recursion, from one function call to another function call, parameter value will change, but not other things. What could be the time complexity to compute factorial? If I give one kick on your nose will become 10 parts. Are Goyal, this is your nose. If I give one kick on your nose become 8 parts. Your nose become 8 parts. If I give one kick on your nose become 8 parts. People are dying to get the concept. He is saying time complexity, he is asking number of stack, he is asking whatever you want. Whatever you want, he is asking. I don't know who is that Maharani will marry you. I don't know who is that Maharani will marry you. She will die literally. She will run away first day only. First day only she will run away. I don't know who is that Maharani. Who is that Maharani will marry you? I don't know. That Maharani will become Maharaja. In one day only she will become Maharaja. Right, go to the next one now. I think 6th point also over. 6th point also over. 7th point. In recursion, from one function call to another function call, parameter value will change, but not other things. Now listen. Can you listen this also? Everyone listen. This small story, can you listen this also? One small story there. Can you listen? Now everyone listen. Can everyone listen? Fact of intent. Carefully observe this also. Fact of intent. Careful everyone. Fact of intent. For, is it visible? Yeah. For I is equal to 1, I less than or equal to n, I plus plus, s is equal to s into I, where s is initially 1. Now lastly printf s. Can you see one small line? Lastly print s. Can you see one small line? Everyone listen. Everyone, can you observe this? Everyone have to get it. Get as maximum as possible. Don't leave like I don't know. Don't leave like I am not getting. Don't do that. Everyone don't know. You have to grow. Day to day you have to grow. No one knows. Now can you see this? One? N value 6 assume. Everyone listen. N value 6. S value 1. N is 6. S is 1. I is initially 1. Careful. So let me check. Is it visible or not? Yeah, maybe not visible, so I am taking another color. Not visible, I am taking some other color. Right, see this one. N value 6. S value 1. One time observe, I is equal to 1 initially I is equal to 1, initially I is equal to 1, right? So run the program, I is equal to 1 less than or equal to 6, condition true, I less than or equal to 6, condition true. See this one, for every condition, see this one, for every condition execute the statement, 1 into I value also 1 into 1 is 1, so S is 1, I is equal to 1, S is 1. Next one, I plus plus, I became 2 less than or equal to 6, condition true. Then S is equal to S into I, S is already 1 into 2 is 2. Next one, I value becomes 3 less than or equal to 6, condition true. Again S is equal to S into I, 2 into 3 6, S value 6. Next one, afterwards I plus plus, I value become 4 less than or equal to 6, condition true. 4 less than or equal to 6, condition true, right? I think true. So S is equal to S into I, 4 into 6 24, I plus plus, I value become 5. Next one, 5 less than 6, 5 less than or equal to 6, 5 less than or equal to 6, condition true again, right? S is equal to S into I, 24 into 5 is 120. So I value became 6 now. I value became 6 now again. So lastly 6 less than or equal to 6, condition true, right? True again. So S is equal to S into 120 into 6, how much? 720, right? 720. Then once again go, it became 7 less than or equal to 6, condition fail. So lastly out of for loop. Can anyone help me? Whenever you are out of for loop, S value how much? Those people who got, please let me know. If not, I will explain again. Just one for loop. It is nothing there, one for loop. It is nothing there, one for loop. It is simply one for loop. How much? Simply one for loop. For loop is running 6 times. Every time S into I. For loop is running 6 times. Every time S into I, initially S value 1, I value 1 into 1. Second time, I value become 2, 1 into 2. Next time, I value become 3, 2 into 3, 6. It's keep on going. So what I mean to say is, listen, if you write the, listen, for the factorial, it is a recursive program. See this one. For the factorial, it is a recursive program. So factorial of 6 is 720. For the factorial, it is a non-recursive program. This is also 720. For every recursive program, non-recursive program is possible. This is the factorial recursive program. See this one? Fact calling fact. Recursion. But see, fact is not calling inside fact. Inside fact, no fact is there. So non-recursion. Fact not calling fact to non-recursion, fact calling fact is called recursion. The purpose of this one is I want to confirm to you, for every recursive program, non-recursive program possible. For every recursive program, non-recursive program is possible. I want to say this. If you want, I will write the non-recursive program again here. See this one? I want to write the non-recursive program again because some people are confused. Into S also. Int S also, S is equal to 1, I also, for I is equal to 1, I less than or equal to n, I plus plus, S is equal to S into I, lastly, printf S. This is the program. If you observe clearly, right, I explained already. If anyone don't know, can you see one time? S is here, N is here, I is here. So initially I value 1, S value 1, N value 6. Continue the loop. I value 1. So S is equal to S into 1. What is the answer? 1 into 1, 1. Next I value 2. Next one, S is equal to S into I. So I value 2. 1 into 2 is 2. This is 2. Next I value 3. So the s is equal to s into I, 2 into 3, 6. This is 6. Next I value 4. S is equal to s into I, 6 into 4, 24. Right? Next I value 5. S is equal to s into I, 24 into 5, 120. Right? Next I value 6. Right? So 120 into 6, 720. It is a 720. Next I value 7. Condition is fail. Condition fail. So out of the for loop. Then printf yes. What is the answer? 720 will be printed. So for every recursion, non-recursion possible. Now final one. Let me conclude finally. Is it recursive program or non-recursive program? Let's conclude. Don't confuse. Get as maximum as possible. Recording also there in your app. I will do the trimming. Trimming of this particular one. I will keep in the app. I will do the trimming of this class. I will do the trimming of this class. I will keep in your app. You can see again and again. Get somehow. Don't by heart. It is a recursion or non-recursion. You will get to know. Is it recursion or non-recursion? Fact calling fact. No. Inside factorial program, fact is not there. It is a non-recursion. Which is also called iterative program. Inside fact is not there. This is a non-recursive program. It is a non-recursive program, which is also called iterative program. Iterative program. So listen everyone now. This is recursive program. Fact calling fact, recursion. Fact calling no one. Right? Now again everyone listen. In the factorial, see, factorial recursion, how many function calls? Factorial recursive program, how many function calls? Factorial recursive program, how many function call? Fact 6, fact 5, fact 4, fact 3, fact 2, fact 1. Factorial recursion, how many? Fact 6 means 6 function calls. Factorial recursive program, fact 6, how many function call? Fact 6, fact 5, fact 4, fact 3, fact 2, fact 1. So 6 function call. Fact 6 means 6 function call. Fact 10 means 10 function call. Fact 100 means 100 function call. But remember, every function call you have to push. In the stack. But when you say non-recursion, listen, when you say non-recursion, fact 6 don't call anyone. So I am writing here. Can you see this one? I am writing here. Everyone listen. I am writing here. Fact of 6 recursive program. Recursive program will call 6 function calls. But fact of 6 non-recursive program will call 1 function call. Fact 6 recursive program will call 6 function call. Fact 6 non-recursive program will call 1 function call. Remember, more function call, more stack. More function calls. So more stack. Next one, less function call. So less stack. Here 1 function call, only 1 push. But here 6 function call, 6 push. Here 1 function call, 1 push. So what I mean to say is, understand everyone. 7th point I am writing. Whatever I done till now, for 7th point only. Can you see the 7th point? For every recursive program, equivalent non-recursive program possible. For every recursive program, equivalent non-recursive program possible. Remember this one. This is a very, very important one. For every recursive program, equivalent non-recursive program possible. I want to say possible. I want to say possible. For every recursion, non-recursion possible. From today onwards, remember, recursion is possible for some problem. Non-recursion also possible. Oi, Arey Goyal, what is going on? Listen, man. Goyal, what is going on? Listen. Afterwards, all will come. For every recursion, non-recursion possible. For every non-recursion also, recursion is possible. Similarly, for every non-recursive program, also recursive program possible. Similarly, for every non-recursive program, also recursive program possible. So it is possible. So what I mean to say is, listen, every recursive program, non-recursion possible. For every non-recursion also, recursion is possible. Both are possible. One to another possible. For every recursion, non-recursion possible. For every non-recursion, recursion is possible. Yeah, next one. Everyone listen. Eighth point. Can you help me now? Who is better for space purpose? Who is better for space purpose? For every recursion, non-recursion there. For every non-recursion also, recursion there. Both are possible. One to another, both are possible. Recursion there means non-recursion there. Non-recursion there means recursion there. Can you help me now? Who is better for space? Recursion contain more function call, more stack. Non-recursion contain less function call because one function call. More function call, more space. Less function call, less space. Recursion means calling itself. More function call, more space. Less function call, less space. Let me write now. Comparing recursive program and non-recursive program. Recursive program will take more stack space. Comparing recursive program and non-recursive program, recursive program will take more stack space most of the time. Write that also. Comparing recursive program and non-recursive program, recursive program will take more stack space most of the time. Comparing recursive program and non-recursive program, recursive program will take more stack space most of the time. Can you help me? Who is easy to write? Recursion, non-recursion. Who is easy to write? Recursion. That is the advantage with the recursion. Recursive program user-like. Non-recursive program system-like. Because recursive programs are easy to write. Users like recursion. Computer like non-recursion. Please careful. Everything having some positive, some negative. No RIC today. No. See the schedule. See already there. Please go and see that. Right? Let me write now. 9th point. Recursive programs are easy to write. So, users like it. But they will take more space most of the time. So, computer don't like. So computers don't like them. Recursive programs are easy to write, so users like it. But they will take more space most of the time, so computer don't like it. So careful, these all 10 points, please take care. Please, these all 10 points, please take care. 10th point. The amount of space, the amount of stack space taken by recursive program is also known as depth of the stack. Please get all these points. 10 points, please get. The amount of stack space taken by recursive program is also known as depth of the stack. Depth of the stack. Can you help me? This recursive program will take how much stack space? Factorial of 6. Factorial of 6 units. Every unit may be 2 bytes. Factorial of 6 units. Every unit 2 bytes. 12 bytes. Factorial of 20 into 2, because everywhere one integer variable required, 40 bytes. Next one, factorial of n. What is the answer? N function call everyone 2 bytes. So 2n bytes. Bytes is a unit, 2 is a constant. Finally, order of n stack space. Recursive program will take how much space? Stack space is known as the depth of the stack. Factorial of 6. So 6 function call, every function call will take 2 bytes. Factorial of 20 function call, every one 2 bytes. Factorial of n function call, every one 2 bytes. So totally 2n bytes. Bytes is a unit, 2 is a constant. So finally n, order of n stack space. So can you see all the points one by one? Don't think that much. Get as much as possible. See, once today's class started, I asked you what is the recursion definition. A function calling itself is known as recursion. I given some example. First example, factorial of 6, how to write, I explained. Next one, factorial of 6, what is the meaning of recursion? A function calling itself. F of n is there, outside f of n, inside also f of n. F calling f, that is called recursion. Okay, one example over. Next one, by seeing this example, I got to know that recursion is nothing but solving big problem in terms of small problem. Next one, because of recursion, many function calls are there, all cannot stay on the main road. They have to store in some data structure. So to execute recursive program, because of so many function calls, we are using stack data structure. So all the function calls are there in the form of a stack. Next one, right? Every recursive program should have termination condition. Whenever recursion going on, calling until termination condition. So every recursive program should have termination condition. Otherwise, we will get error message stack overflow. This is a runtime error. Please take care. Every recursion should have termination. Otherwise, stack overflow error message, which is the runtime error. Next one. Those are the 4 points. Fifth point. I think where is the 5th point? 4th point is okay. Where is the 5th point? Yeah, let me check 5th point. Yeah, whatever it may be the number. So 5th point, right? So this is the 4th point. See the 5th point. 5th or 6th, whatever it may be. In recursion, from one function call to another function call, parameter value will change, but not other things. In recursion, from one function call to another function call, parameter value will change, but not other things. So I explained clearly. See this one. Function name also same for all the people. All the people function name also same. Parameter name also same. Number of parameters also same, but the only thing is value will change. When recursion going on from one function call to another function call, parameter value will change but not other things. Next one. For every recursive program equivalent to non-recursive program possible. For every non-recursive program also recursive program possible. Next one, comparing recursion and non-recursion. Recursion will take most probably more space because of more function call. Comparing recursion, non-recursion, mostly recursion will take more space because of more function calls. Next one, recursive programs are very easy to write, so users like it, but they will take more space most of the time, so computers don't like them. Next one, 10th point, the amount of stack space taken by recursive program is also known as depth of the stack. Please take care all these 10 points. Don't confuse a little bit also. Recursive programs are easy to write, so users like it, but it will take most of the time more space. Computers don't like it. The amount of space taken by recursive program is also known as depth of the stack. So please read again and again. Read. If you read again and again, you will be more comfortable. You will read again and again, you will be more comfortable. When I am doing the first time, I also face a lot of difficulty. When I am doing first time, I also face a lot of difficulty. Please do again and again. Please do again and again. No one will be comfortable in one round. No one will be comfortable in one round. If anyone asks you from today onwards, what is recursion? Please give this lecture. Please give this lecture. Anyone asks you in the interview, please explain recursion. Please explain these 10 points. Arey, Goyal man, I didn't done the conversion. I just taken one example. They will come afterwards. Don't kill me. Don't kill me. I didn't done the conversion. I simply take one example. I explained. Conversions and all, everything will come after. Don't kill us. They will come after. In one of the class it will come. Right? So that I said already. See this one. I said already. Why recursive programs are there? Recursive programs are easy to write. Users like it. Non-recursive programs are difficult to write. Users don't like. Non-recursive programs are difficult to write. Users don't like it. Recursive programs are easy to write. Users like. If users like, you have to give that flexibility. At the end of the day, user should be happy. If user is not happy, he don't buy computer at all. If user is not happy, he don't buy computer. If user not happy, he don't buy computer. He like recursive program to buy recursive I am repeating once again. He like recursive program to write recursive program. He will buy computer. After buying computer, he started writing. He got to know it is taking more space. How to save it? He may write non-recursive program afterwards. Everything having some positive, negative. Recursive program better for user. Non-recursive program better for space. The amount of stack space taken by recursive program is also known as depth of the stack. Right? Recursive programs are easy to write, so users like it. Now once again I am saying to you, without seeing all the 10 points, I am saying one by one. Can you see this? When you do again and again, it will become so easy. Without seeing the right class also, I can say one by one point. First point, see, first point. Recursion, right, means calling itself. Recursion means calling itself. Another way of saying recursion, solving bigger one in terms of smaller one. Next one, recursive program to execute, we are using stack data structure. Next one, recursive program to execute, we are using stack data structure. Every recursion should have termination, otherwise stack overflow error message will come. Next one, when recursion is going on, one function call to another function call, right? Parameter value will change, but not other things. For every recursion, non-recursion possible. For every non-recursion, recursion also possible. Comparing recursion, non-recursion, recursion will take more stack space because of more function calls. Non-recursion will take less stack space because of less function call. Next one, the amount of space recursive program will take, which is known as depth of the stack. The amount of space recursive program is taken is known as depth of the stack. Are you fine now? Yeah. Next. If anyone, right, this one. If you right, please go everyone. Please like the class. Please like the class. Arey Goyal, you should like 20 times. Goyal, you should like 20 times. Goyal should like. Goyal like 1,000 times. 1,000 times you like. You tortured us. You tortured me. Please like 1,000 times. Goyal, you like 1,000 times. You tortured me. Everyone should like. If anyone don't like, please let me know. This will come in the interview. Explain. Listen. This will come in the interview. Explain recursion. This will come in the interview. I don't know how many people will get this. I don't know how many people will get this. Really, I don't know how many people will get this one. At least few people will get in the interview. Please explain recursion. In the interview, if you little bit lucky also, in the interview you will get this. Please explain recursion. Please explain total. 1 hour you have to explain. He will beg you, please stop. He will beg you, please stop. Please stop. Don't stop. 1 hour explain. Explain recursion. Explain recursion. 1 hour explain. 1 hour literally how to explain. He will give the job. Trust me, he will give the job. 1 by 1 point explain. Yeah, 1,001 is better. 1,001 is better. I feel 1,001 is better. Yeah, 1,001 I like it. Yeah, please share it to your friends also. Please share it to your friends also, and make sure one class also you don't miss. Make sure one class also you don't miss. If you miss one class also, you don't get further. And tomorrow there is a status call, status checking. Tomorrow there is a to your batch. Tomorrow there is a status checking. Right? What is going on? What is happening? Right? How much preparation? There is a status checking. There is a tomorrow at 6 o'clock. Tomorrow at 6 o'clock. What is the time? Tomorrow time? I posted already in the group. What is the status checking time? We have Zoom call tomorrow, right? At around 6 o'clock. Someone is saying, please don't leave topic. People will die. Arey reality. Arey how? They cannot eat or what? 6:45 to 9 now. So yeah, so we'll see in tomorrow's class. Thank you so much. And one more. If anyone is not joined, see this one. New batches are starting for right? DSA classes. One new batch is starting for DSA classes. One more new batch is starting for GATE CSC. One more new batch starting for GATE DA. These 3 batches, right? New batch is starting. Right? My suggestion is, if you are serious, you can please go through it. You can WhatsApp me to the number, right? To this number you can WhatsApp me. Right? Or you can go to the exam prep tool app. exampreptool.com. You can subscribe from there also. New batches are starting for these 3 DSA classes, GATE CSE and GATE DA. If anyone is not taken subscription, you can take. Because right, approximately 80% classes are inside app. 80% classes are inside the app. 80% will be there inside the app. 20% will be outside. Right? You may not get anything if you attend only YouTube classes. My suggestion is, right? Please take the subscription so that syllabus will be completed as soon as possible, so that you will get the enough time to practice. Who will teach in gate DA, right? Remaining people, right? Remaining subjects, remaining people, right? Fine. Thank you so much. Thanks everyone. Tomorrow in the status meeting we'll check. Please don't miss status meeting, status checking meeting. Please don't miss it. If you are facing any difficulty, you can come and ask, right? That particular, right? That every right, every, I think maybe every Saturday we have, Saturday or Sunday we have status checking, so that if you are facing any problem, right, we can resolve it. Thank you. Good night everyone.